What's up guys, this is Massey. Welcome to another video. In this video I want to show you what is a nilpotent matrix. A square matrix A is called a nilpotent matrix if there exists a k that belongs to natural numbers such that a to the power of k equals to 0. And k is called the index of the nilpotent of matrix A. So k is important. And a to the power of k is going to be 0. For example, when we have a equals to 0, 0, 0, and 2, if we find out a squared, that's going to be 0, 0, 0, 2, 0, 0, 0, 2, multiply with each other, that's going to be 0, 0, 0, and then you have 0, it's going to be 4. If we find out a to the power of 3, which is going to be 0, 0, 0, 4 times 0, 0, 0, 2. When you multiply it, that's going to be 0, 0, 0, and the last one is going to be 8. So that's not a nilpotent matrix. However, if you define B 0, 1, 0, 0, when you find out B squared, it's going to be 0, 1, 0, 0 times 0, 1, 0, 0. It is going to make it as 0, 0, 0, and 0. So B is a nilpotent matrix and the index is 2. Next example, if we have matrix M, that's AB, B squared, negative A squared, and negative AB. And I want to find out B squared, which is going to be AB, B squared, negative A squared, negative AB times self, which is going to be AB, B squared, negative a squared, negative ab. We want to find out if it's going to be 0 or not. If it's 0, we call the nilpotent matrix. So that's supposed to be 2 by 2 as well. So ab times ab is going to be a squared b squared minus a squared b squared, ab cubed minus ab cubed, negative a squared b plus a cubed b, and negative a squared b squared plus a squared b squared. As you see here, all the elements is going to be 0, and we can say that M is a nilpotent matrix of index 2. Let's see another example. We have matrix N 1, 2, 3, 5, 2, 6, negative 2, negative 1, and negative 3. We want to find out if it's a nilpotent or not. If it is, what is going to be the nilpotent matrix of index, or index of the nilpotent matrix? So n squared is going to be 1, 2, 3, 5, 2, 6, negative 2, negative 1, and negative 3. Multiply by itself. When you multiply, it's going to be 1 times 1, 1. 2 times 5, 10. 3 times negative 2, negative 6. 1 times 2, 2. 2 times 2, 4. 3 times negative 3. 1 times 3 plus 12 minus 9. Next one, 5 plus 10 minus 12. 10 plus 4 minus 6. 15 plus 12 minus 18. Then we have this times this, negative 2, negative 5 plus 6, negative 4 minus 2 plus 3. And finally we have negative 6 minus 6 plus 9. So now what we can do, simplify it. 11 minus 6 is gonna be 5. 6 minus 3, 3. 15 minus 9, 6. We have 3, 8, 9, negative 1. Here we have negative 3 and negative 3. Then you multiply it by another 1. 1, 2, 3, 5, 2, 6, negative 2, negative 1, negative 3 times what you got in here, because a squared is not 0, so we try to have a cube. So we have 5 plus 6, 5 plus 6 minus 3. It's going to be 8. Then you have 3 and 16 and negative 9. It's going to be 10. 6, 18 and negative 9. 15. 25, 6 and negative 6. 15, 16 and negative 18. 30 plus 18 minus 18. Negative 10, negative 3 and positive 3. Negative 6, negative 8 and positive 9. Here negative 12, negative 9, positive 9. So as you see here, this one is not a nilpotent matrix. Let's have another example. I'm gonna change it a little bit. I'm gonna have C equals to 1, 1, 3, 5, 2, 6, negative 2, negative 1, negative 3. And now, when I multiply it by itself, in order to have C squared, we're gonna get this times this, 1 plus 5 minus 6, that's gonna be 0. 1, 2 and negative 3, that's gonna be 0. 3, 6 and negative 9, that's gonna be 0. 5, 10 and negative 12, that's going to be 3. One more time. 5, 10, negative 12, which is going to be 3, yeah. 5, 4, negative 6, which is going to be 3. 15, 12, and 18, it's going to be 9. And then you have negative 2, negative 5, and 6. It's going to be negative 1. Then you have negative 2, and positive 3. Negative 1. Negative 6, and positive 9. Which is going to be negative 3. Now what we can do, we multiply it again in order to have c to the power of 3. 1, 1, 3, 5, 2, 6, negative 2, negative 1, negative 3. And here we have 0, 0, 0, 3, 3, 9, negative 1, negative 1, negative 3. That's going to give us 1 times 0, 1 times 3, 3 times negative 1, that's 0. 1 times 0, 1 times 3, 3 times negative 1, 0. 1 times 0, 1 times 9, 3 times negative 3, 0. 5 times 0, 2 times 3, 6 times negative 1, 0. 5 times 0, 2 times 3, 6 times negative 1, 0. 0, 18, negative 18. 0, negative 3, positive 3. 0, negative 3, positive 3. 0, negative 9, positive 9. That's going to be 0. So we're going to say that C is a nilpotent matrix of index 3, because C3 is going to be a 0 matrix. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.